Welcome to the lecture series on deep learning in artificial neural networks. This video covers careful cross-validation. Previously, I told you that the total number of P data points needs to be split in two parts. The new thing now is that this second part will be put aside as a test base. You have to consider that future data, it's never to be touched. Don't touch it, don't look at it at no stage during learning. Therefore, you only have P1 data points now to optimize all parameters. And this means the weights of the network itself, but also the hyperparameters. And therefore, we need to split this again into two parts, a training data part that we use for gradient descent and a validation data set that we use to adjust the hyperparameter lambda. Normally, you have to do this split yourself. However, for the MNIST training data that I mentioned before, the split was done for you. So at the very beginning, Jan LeCun put aside 10,000 data points as a test base that is really future data that you never touch. And you are only given 60,000 data points, which form the official training base. And now, you do your private second split into training data and validation data. And this is how we do it in practice. Here's your data. You put aside your test data that's never to be touched. Now for the rest, you have removed now this part. And now you do a second split and you say, let's put aside some part, for example, this part here, and call this the validation data. And then you do this second split k times, you repeat it. So, for example, this data here, or this data there, or this data here. Each time you put aside some data and you repeat this k times until you have used all the data here. And then you average over the result and you repeat the whole procedure for different values of lambda of your regularizer, and then you pick in the end the lambda that gives the best performance on this average over your k folds of the data. Careful k-fold cross-validation is an accepted performance measure. If you look at papers published in the big conferences, they all use this kind of validation procedure. In principle, once you have done your k-fold cross-validation and found the optimal lambda, you can take this lambda and retrain with that lambda on the whole training base. So you no longer move out one fold for validation because you already have validated. And then this new parameter set could be tested on the future data. In practice, people rarely put aside test data that is never touched. So they only do careful cross-validation, and this is accepted in the community of machine learning.